Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acetal formation from an aldehyde or ketone reacting with a diol. Moving on to the next step. Examine the product. In the product, the CH2O from the primary alcohol at C1 and the oxygen at C2, secondary O, have both reacted with a single carbon bearing a pH group and one H, forming a 1,3-dioxolane type cyclic acetal. The acetal carbon bears pH and H, which means it came from an aldehyde IChO where R is equal to pH. Moving on to the next step. An acetal is formed when an aldehyde reacts with a 1,2-diol or 1,3-diol. Here, the CH2O at the top, C1, and the O at C2 form a 5-membered cyclic acetal with the aldehyde carbon, giving a OCH, pH, O bridge. The acetal carbon has one H and one pH substituent, consistent with benzaldehyde, PHCHO. And for the final step. If the reagent were acetophenone, option A, the acetal carbon would bear pH and CH3, no H. If it were phenylacetaldehyde, option C, or phenylestone, option D, the acetal carbon would bear pH CH2 rather than pH directly. Only benzaldehyde, PHCHO, gives an acetal carbon bearing exactly pH and H. A acetophenone would give acetal carbon with pH and CH3, not pH and H. C. Phenylacetaldehyde would give acetal carbon with pH, CH2 and H. D. Phenylestone would give acetal carbon with pH, CH2 and CH3. Therefore, the correct answer is B. Therefore, the correct answer is option B.